Greetings, everybody. Hey, welcome to Lab 10. This is the HR Diagram Lab, a powerful lab that teaches you all about how stars works. And by the way, this is the next to the last lab we're going to have. The last one will be galaxies classifications. The Unit 12 lab is going to become an extra credit lab. You should check on the website, and I'm going to tell you all about that shortly. But let's get back to this one. This is a big, important lab that's fun to do. One of the things you can see on it, for example, before I get to that, let me remind you that this thing is due on July 21st, as usual. You'll actually get access to it on Monday, July 13, in the morning, as usual. What I would suggest you do is we're going to do this lab now with reference to the student guide. So if you haven't done so, please print out the student guide now. We'll wait for you. Okay, now that you're back, you've printed out your student guide. I want to go through some specific things with you in a minute. There are reading assignments for this thing. One's in Seeds. It's on page 151, a few pages there on the HR diagram. Also, the background pages, which I'm showing you now. This is the home page for the lab, by the way. And we can click on this one in particular down here. I want you to read all three of these. This shows you a really nice shot of everything to do with spectral lines that you need to know, everything to do with stellar spectra, from O to M right there. Here's a nice shot of Annie Jump Cannon, who invented this technology about 100 years ago, give or take. Some beautiful shots of radiation curves that explain to us how stars work. Here's the actual spectral types with temperature information and color. Then at the bottom, there's a very nice little practice exercise that we're going to click on here, and it'll show you exactly how to use this. In fact, let's go to the first page now of the student guide, page 1 at the top. It has some columns with names, and what it wants you to do, if we look at the Betelgeuse row, it wants us to go to M, spectral type M2. So we just move this little thing over here like this. There it is on M2. Whoops. There you go. There's M2. Notice the temperature of the stars down here. Notice the color of the stars over here, and you just put those things right on the first row. That's all there is to it in this part of it. The second one has to do with a little bit of arithmetic on page 1, but the numbers are all small, and so I don't think that will cause you any particular trouble. If we go over to page 3, let's go back to the actual simulation now and see if we can bring that up to us here. Yeah, there it is. Okay, there's the actual simulation coming up. There we go. This is what it looks like. This is the HR diagram. It stands for Hertzsprung-Russell, by the way. About 100 years ago, they created this thing. This is one powerful little module, believe me. Here we're looking, here's the HR diagram over here on the right, but we'll get to that in a minute. Here's where the arithmetic is done, and notice we have temperature down here, luminosity and radius. We can choose and adjust the temperature by using this little guy right here. We can choose and adjust the luminosity, and the radius of the star is automatically computed for us right here. Notice I've put them on the sun, but we can move them out easily. Notice that when I increase the temperature, when the luminosity stays the same, the radius has to go down, and it all happens magically, automatically. Now, the cool thing is that the HR diagram over here is linked to that set of calculations, and I'll show you how that works in just a second. Since this is an HR diagram, notice its luminosity increasing upward in units of solar luminosities, and here we have temperature in Kelvin degrees, going from low temperatures to high temperatures on the left. Very important point here. And I want to show you the main sequence. These are the stars that burn hydrogen in their cores. It's about 90% of the stars in the galaxy, including the sun, that actually do that. Now watch this. This is very powerful. When I put the cursor here and click on it, notice what just happened. The calculator over here picked up immediately where the cursor was, picked up the luminosity and the temperature. Here they are. Temperature is 9,800 degrees. Luminosity is 28 times the sun's luminosity. And notice the radius is quite large. It's about twice that of the sun. And we can make that change anytime we want. It doesn't have to be on the main sequence. It can be down off the main sequence. It can be on the main sequence, and so forth. So let's go ahead and see how this works. Question number 4. Hot stars are found where? This is pretty easy because the temperature increases to the left. So if we click over here, notice that what happens is that the temperature of the star just went to 25,000 degrees. And we can click up and down this corridor, and the temperature of the stars will always be hot on the left side. So the answer is left. That's all you have to do on that one. The question 5 is more interesting. Let's take, say, large blue stars are found where? Well, we want blue stars and we want large stars. So let's do this. We can put in the isoradius lines. This is really a nice feature. Notice here is one solar radius right here. All the stars on that line have the same radius. Here's 10 solar luminosities. Here's 100 and here's 1,000, and the small ones are down here. So they want to know, where are the large blue stars? Well, we know that they're going to be up in here somewhere. Let's check that. Okay, notice, large blue star. Let's go over here. Let's check the upper right corner. Do you see any large blue stars over there? Well, if you look, this is not blue. It is large, but it isn't blue. Down here in the lower right corner, notice the stars just got small, and they also got red. And over here, we're looking at stars that are very small. So the easy way to answer these questions is to just try all 4 corners, and whichever one looks like what you want, the answer is upper left. Just that simple. Now, let's see. The next pages really are asking you questions. The little plotting exercise on page 5, I think you'll pick up on that real fast. Let's go over to page 6 and look at that. It says, check the plotted stars option for the nearest stars. Let's go ahead and put that in. We'll get rid of the isoradius curves. And we just click on the nearest stars, and there they are. Isn't that interesting? Notice the nearest stars are right here. They're all down in the lower right corner. Those are red dwarfs and sun-like stars. And notice this one right here. Let's click on it just for fun. And now we know its luminosity is 23 times that of the sun, and its temperature is 9,500 because the calculator on the left told us stuff. So, and it's just about 1.8 solar radii. What does that mean? The question is, what's the mass of this object? You can actually calculate that. You'll see that the mass of this object is less than 3 solar masses. That's comforting. I'm comforted. I feel better already because I know, and so do you, I think, most of you, that the mass of a star has to be over 8 solar masses before it can go supernova. So that means that none of these stars will ever blow up like a supernova. And that's comforting because if we had a lot of supernova potential stars in our vicinity, we wouldn't be around long. It's not a coincidence. But anyway, all they're asking you to do is talk about the range of temperatures, colors, luminosity, and sizes. That's easy. We just click up here, and then we look over here at the temperatures and the luminosities and the radii, and we click down here at the other end, and we do the same thing. Notice the temperatures, luminosity, and radii are much different. That's how you answer those questions. You just click, and the whole thing works for you. Now, over on page 8, we get to the fun stuff. I gave you some notes here on the actual sheet, which you can use, but the way to do this thing is, I'm looking at the bottom of page 8, question number 16 right now. The question is, how do you fill out these tables? There's a table, a temperature over solar temperature in units of solar temperatures table on the far right. And I put in the 4th root of 10 is 1.78, so you don't have to worry about that number either. And you can either do the easy arithmetic here, or you can use the simulator. Let me show you. I'll give you one example how you can use the simulator. Let's go down and use it for row number G. And we're on page 8, looking at question 16. What we want to do here is they give us the radius, it's 100 solar radii. They give us the temperature in solar temperatures, which is twice the sun's temperature. And they give us, they want us to find out what the luminosity is. To do this, we have to convert 2 solar temperatures into the sun's temperature. Write this down. The sun's temperature is 5,800 degrees Kelvin. That's the sun's temperature. So what you have to do, and I gave you the instructions for this, simply multiply in row G, that's the example we're looking at, multiply 5,800 by 2. 5,800 by 2 is about what? It's 1,100. It's 11,600. That's what it is. 11,600. So that's the temperature you should be using in row G. Write that just to the right of the 2 there. So now we know the temperature and we know the radius, and we can actually go into the simulator and let's, over on the left side where I am here, let's set the simulator for 11,600. This is a powerful little thing. There's 11,600. We'll put it at 1,200. And then we want this thing to be 100 radii, so we have to adjust the luminosity. Watch what happens to the radius when I start moving the luminosity to the right. We want it to go up to 100. It's big. And notice we're going to make it. In fact, it was easy. Hang on. There it is. I had it. There it is. That's 100. And now all we need to do is to just read off the luminosity. It says 180,000. And that's the way you can do this without any arithmetic at all. Or you can do it the arithmetic way and use that little equation I gave you. And now we've got the temperature, which is 11,600 for row G. We can do the same procedure for all the other rows. Just watch that over again if you missed what I did there. And what we do next is simply go to the next page and plot these numbers up on page 9. We plot them on the HR diagram. You plot the luminosities, the second column on the left, and we plot the new temperatures on the far right column, which are in degrees Kelvin, not the ones that are actually shown there, the ones we had to multiply by 5,800. And I'll show you, let's show you how you can plot 180,000 on this interesting graph. That's not on the screen now. I'm looking at page 9 now. If we wanted to plot 180,000 for the luminosity, we simply go up to the left, the y-axis, and see where it says 10 to the 5th? That's 100,000. So the first tick above 10 to the 5th is 200,000. They just go up by once. The first tick is 200,000, the next one is 300,000, then it's 400,000. It'll go all the way up to 1,000,000, which is 10 to the 6th. So somewhere about almost to the second tick is where you would plot the y value for 180,000. And the actual temperature for the star is easy. That's 11,600. That goes just to the left of 10,000 in this diagram. So that should get you started. By the way, if you have any trouble with any of this, it's not really very tangly, but since I showed you a way to avoid the arithmetic, you've got it made. But contact me if you have any problems.